All right, so we're on page 2 of our review booklet. This is Unit 1, Sequences. So you reviewed sequences a little bit last week. Remember that a sequence is a list of numbers in a specific order. So this phrase right here, remember this means f of 1. That's how we're going to read that. F of 1 is a way of representing the first term of the sequence, the number that appears first in the list. You know that there are two types of sequences. So the first one is an arithmetic sequence. And in an arithmetic sequence, we have what's called a common difference, which is the number that is added, or sometimes we think of it as subtracted if we're adding a negative number. So the common difference is what's added or subtracted to get from one term to the next. On the other hand, we might have a geometric sequence, which has a common ratio, and the common ratio is the number that is multiplied from one term to the next. So arithmetic, geometric, both of them have a first term. The difference is one is addition and subtraction, the other one is multiplication. So the next thing we had was explicit formulas for each of these. So let's start with the arithmetic sequence. So remember this phrase right here, we say f of n, f of n. So the formula for an arithmetic sequence always looks the same. We've got some number times n plus another number. So the first box, the one that's multiplied by n, is our common difference. That one at the end there is the 0th term, which can sometimes get a little bit confusing because we don't usually see it. There's no such thing as the 0th spot in line. So let's look at what this means with an example. We've got the sequence, the list, 3, 12, 21, 30, 39. So between each term, looks like we are adding 9. 3 plus 9 is 12. 12 plus 9 is 21. 21 plus 9 is 30. And 30 plus 9 is 39. So we've got our common difference, which is 9. So as we start to write our formula, we can write f of n equals 9n. Now we have to think about what is that 0th term. To do that, I would suggest working backwards. 3 is the first term. So to work backwards, instead of adding 9, we're going to subtract 9. Then what do we get? 3 minus 9 is negative 6. So we end up with a 0th term of negative 6, which means that at the very end of our formula, we write a minus 6. So f of n equals 9n minus 6, and that would give us this sequence in a formula form. If we're talking about a geometric sequence, we've still got really similar parts to this. It's just the structure that looks a little bit different. So remember, first thing is our variable is always in the exponent. This is not times n, this is raised to the power of n. That number that's being raised to the power of n is our common ratio. And just like with the arithmetic sequence, we always want to think about the 0th term as well. So our example, 7, 14, 28, 56, 112. Well, if I think 7 times 2 is 14, 14 times 2 is 28, 28 times 2 is 56, and 56 times 2 is 112. Well, that means that our common ratio must be 2. So we're starting our formula here. We know that there's something multiplied by 2 raised to the power of n. So our 0th term, just like with the arithmetic sequence, we worked backwards by kind of using the opposite operation. We're going to work backwards here. So working backwards, the opposite of multiplication is division. If I divide 7 by 2, I end up with 3.5, which makes our 0th term 3.5. So our function becomes f of n equals 3.5 times 2 to the power of n. So we've got all of our work in there. So if we're given a list, our sequence as a list, we can always write a formula for it. Now let's talk about what we can do if we are given a formula. So now we're on page 3. Multiple representations means that we can make a formula, a table, and a graph all represent the same sequence. So f of n equals 2n minus 1. So the first thing I might ask myself is, what type of sequence is this? Well, this is arithmetic. Just a good way to check. Like, I know that it has the form of an arithmetic formula, so I'm going to keep that in the back of my mind so that the rest of my representations match that. Now, in order to make a table from an equation, we plug in values of n. So we plug in a number for n here and evaluate it using our order of operations, and we come up with a value of f of n. So as we fill out our table, our first value is 0. So I'm going to do negative 2 times 0 plus 9. This is 0 plus 9 makes our f of n value 9. Okay, we can keep going. Negative 2 times 1 plus 9. Negative 2 times 1 is negative 2 plus 9 gives us negative 7. So if you're not as comfortable with just using the structure, adding or subtracting the same number every time, this is a foolproof method. Like, you cannot go wrong if you know how to plug a number in for n and use the order of operations. Oops, you see what I did there? I wrote negative 7. That should be positive 7. Get rid of that. All right, so I keep evaluating this. We say that's 5. Negative 2 times 3 plus 9. It's negative 6 plus 9 is 3. Negative 2 times 4, plus 9 is 1. And negative 2 times 5 plus 9, that's negative 10, plus 9 is negative 1. So, looks like my table follows the pattern. I know it should be subtracting 2 each time, and my 0th term is 9. To make my graph, we want n on the horizontal axis, f of n on the vertical axis, and I'm going to make mine kind of spaced out a little bit here on the n axis. You can label this however you want as long as you're consistent. And I'm going to make these go up just by 1 here, 3, 4, 5, 6, 8, 9, and so on. So now as I start to graph, I've got the point, this is 0, I've got 0, 9, 1, 7, 2, 5, 3, 3, 4, 1, and then 5, negative 1 is off the screen, and I'm just not going to worry about it. So we've got a table, we've got a graph, a graph, a table, and a formula all representing the same sequence. We do the same exact thing with whether it's a geometric sequence or an arithmetic sequence. So again, plugging in a value for n here. This one just requires a little bit of finesse with the calculator, knowing how to use those exponents. This is 1/2 to the power of 0. This is I do the exponents first, order of operations, so I start with the exponents. So that's 400 times 1, 1/2 to the power of 0 is 1, and this makes a grand total of 400. So 400 times 1/2 to the power of 1, that's 1/2 times 400 is 200. So again, as long as we're using our calculator responsibly and starting with the exponents, we're never, ever, ever going to do 400 times 1/2, then raise it to that exponent. And in fact, I should probably write the correct exponent there. All right, so this is 100, and we keep working here. This is 50, 400 to the power of 1/2 to the 4th, that's 25. And last one here, 1/2 to the power of, not 4, we already did that one, power of 5. We get 12.5. So again, making our graph, we can make our scale whatever we want it to be as long as we are consistent. So I'm going to go up here, call this one 400, call this 100, 200, 300, so it's like each little tick mark is 50. So I plot my points, reaching my limit here. We're going to make it. All right, so there's our graph. So you can use this, get to work on your practice. You can also use your digital portfolio, your digital overview. If you need extra assistance, good luck, and I'll see you tomorrow.